Hello students, today we're going to take a look at elimination. This is actually part 2, and this will be where we have to set it up using multiplication. So at times when we're given two equations in standard form, that is where x and y are on the same side, sometimes there will not be a coefficient that matches with the x or y variables. So however you want to think of it, but basically we don't have a match, we don't have stacked stacked x's or stacked y's that will cancel out. So we have to manipulate things. So we must multiply all parts of at least one of the equations by a number to set up one of the variables to be eliminated. So that's what we're going to be looking at doing here. All right, so let's go ahead and take a look at an example. And when I say coefficient, one thing I forgot to say, coefficient is the number out front. So the coefficient here is 2, this coefficient is 5. This coefficient it would be a 1 and a 2 right there. So just to review coefficients real quick. All right, so when we look at the matches, 2 and 1, 5 and 2, nothing readily cancels out. So we need to figure out what would be easiest. So, 5 and 2, we'd actually have to multiply both. So if we could multiply this one, so we're going to multiply the bottom one by 2 to get the same coefficient, but we also need a positive and a negative. So we're actually going to multiply by -2 because this one is +2. So that way we'll get what we want and get things to eliminate. All right, so then we are going to have 2x plus 5y equal to -1. And then this one we're going to distribute. And I know I put the parentheses around the whole thing. We could write another -2 over here, but we're essentially multiplying both sides by that -2. So -2x minus 4y, and then -2 times 0. Don't forget the last one. We get 0 right there. So now, once we've done that, we kind of manipulated things to help us. Now we've got the x's right here set up ready to eliminate. So that's what we're going to do now. So those eliminate. We get 5 minus 4, we get 1y, or just y, and equals -1. So as far as our ordered pair answer, we can now fill in that y is -1. And then the elimination part is over now, and we're going to have to actually use substitution here at the end. So we can pick this one, or even the new one, as long as we multiplied correctly. Any of those would work. I'm actually going to go back to this one because it's x by itself. So x plus 2 times y, which is -1, is equal to 0. So for that we get x 2 times -1 minus 2 equals 0. We add the 2, and so we're going to end up with x equals 2. So up here in our answer we get to -1. So there you go. Feel free to pause at any moment if I get going too fast, because now that we've kind of explained it, I'll work through each question. We'll keep moving here. So for this one we look at 2 and 6, 3 and 12 as our coefficients here. So I'm going to multiply to eliminate the x's, but we could actually, because this is plus and negative, I'm going to go ahead and eliminate the y's. There are options. There's not only one way to go about these to get a correct answer. So since these are already plus and minus, it's not that much different. So what times 3 will give me 12, so I'm going to multiply by 4. So I'm looking to cancel out the y's right here, and I'm going to bring this down and actually just keep this one and write it underneath. So I get 8x, 4 times this one, I get -12y, and 4 times that 4, I get 16. All right, so that's what I chose to do. Again, you could multiply the top one by a different number to cancel out the x's. So there is parts of these that are entirely up to the person solving the equation, solving the system, and how it works best for you. All right, so when I do that, I get what I want right here with the y's. So I'm going to have 14x that I combine. These combine to cancel out, and these get me 42. So then when I divide by 14, I'm going to get x equals a +3. Okay, so in my answer, I've got x is 3, so be careful, always make sure we get x and y in the right spots. You can pick whichever one you would like to plug it back into. I'm just going to take this one this time. So 6 times the 3, we got plus 12y is equal to 26. So I'm running out of space there, so I'm going to move it up over here. 6 times 3, we get 18. Is equal to, plus 12y is equal to the 26. So we're going to subtract 18 when we do that, we've got a 12y to bring down, because this is plus, sorry about that, equals 8. So when we go to divide, we don't get a nice round whole number. However, it does simplify into 2/3, so that's okay. We can have a fraction for an answer sometimes. There we go. And always remember, you can take these and plug it back into either to double check to make sure that it works. All right, so there's the first two. That's a lot of work there. We multiplied through one of them by one number so that we could get them to cancel out. So we're going to go ahead, feel free to pause that if you need to catch up. And then let's go on to this one. So I look at the x's, look at the y's. I'm just going to look and see I've got plus and minus, so I'm just going to multiply this times a 3 because I know 3 times 5 is 15, so that one will cancel out. So I distribute. I'm going to bring this down. I get 15x minus 27y is equal to 3. And so when I do that, now the x's cancel out like I wanted, but actually in this one, the y's cancel out as well. So I just end up with 0, because 0x plus 0y is just 0. And here I get 0. Now, we go back to the last substitution lesson. We did a substitution lesson on when this happens, when the variables drop out. If we have a true statement, that means it is infinitely many solutions. So that's all we have to do on number 3. If we had everything drop out and we get a false statement, like 0 equals 10 or something like that, that is when it would be no solution. All right, so let's take a look at this one. This time we got, again, the x's we can make work. So I'm going to multiply by a 13 down here to match up the x's, but I need one of them to be negative. So you could multiply the top by negative, but I'm just going to do it all at once. Okay, so this time I'm going to have to rewrite these. 13x plus 26y equals negative 5. I distribute everywhere. I get negative 13x minus 26y. Oops, I forgot that again. That's 26 right there. And don't forget to multiply the last one. Negative 13 times 5, we get negative 65. So this one ends up, the x's drop out. The y's actually drop out again. And this time we get negative 70. So when that happens, 0 is definitely not equal to negative 70. That is when we get no solution. So there's one of each right there if you want to pause and update that. Okay, we're just going to go ahead and go to the next page now that we got that one taken care of. All right, so now we're going to look at sometimes it will not be possible to multiply only one equation by a number. So everything we did on that last page, we only multiplied one of them by a number. So this time we will need to multiply both equations by their own number to manipulate the eliminated value, or eliminated variable, I should say. So we're going to have to multiply both the top and the bottom this time to make this work, because we look at the x's, we got 2 and 5. 2 doesn't go into 5. And then look at the 3 and the 2 for the y's. 2 doesn't go into 3. So we're going to have to manipulate this somehow and multiply both. Now again, there's a lot of options that you have. It really is up to the person solving as to which one works best for them. So I look, since I've got plus and minus, that way I don't have to worry about the signs. I'm going to go ahead and multiply the top by the 2 and the bottom by the 3. Now you don't always have to use these two numbers. If they're bigger numbers, you might be able to have them multiply into a smaller number, so you don't have to get such big numbers to deal with. But the 3 and 2 are small enough, so no big deal here, hopefully. All right, so we're going to distribute. Because the whole reason we picked 3 and 2 is because up top we're going to get 6y, on the bottom, when you go here, you get minus 6y. So that's what I mean by we're manipulating this so that we can get things to work out to our advantage. We're just thinking a couple steps ahead. All right, so we get, and then we multiply here, so we get 8. And then on the next row, we're going to get 3 times 5, so 15x. We get minus 6y, which that creates exactly what we wanted right there with the 6y and the minus 6y. And then 3 times the 10, we get the 30. So don't forget that last one. We could write the 3 over here. I just typically write it over here with the parentheses to save space and time. All right, so we combine x's, we get 19x. The y's eliminate, and we get 38 over on the far right column. I'm going to divide by 19. When I do that, I get x equals 2. So there we go. So it works out nice. We got the elimination. Now this time you actually have 4 options. You could go back to one of the 2 originals or one of the 2 new ones to plug it back in, because we've got our x value is 2, and then we need to figure out what our y value will be. I'm going to go back to the first one since it had the lowest value. So 2 times x plus 3y is equal to, it was 4. So we're going to plug that in. The x was 2, so 2 goes right here for x. 4 plus 3y equal to 4. We're going to subtract the 4. And when we do that, we're going to get 0. Now, interesting thing happens here. We get 0. Now that doesn't mean there's no solution or anything because we still have a variable. So we divide by 3. And so 0 divided by 3, that's not like when we did undefined slope or anything. This is actually 0 divided by 3 is 0. So you can test on your calculator. So our answer ends up being 2, 0 right there. And that's okay. That's certainly a solution that does work when you plug it back in. All right, last one. And for this one, we've got 8 and 12, 4 and 6. So I always kind of look at my matches and see what I need to do to make this work. So 4 and 6, 8 and 12. It's really like again, it's up to you. Last time I did the y's. This time I'm going to take the x's. But again, you can pick and choose to manipulate how it is, whatever your mind thinks of first. So to me, I think 8 and 12, I know they both go into 24. Okay, so I'm going to take and multiply the 8 by 3 and the 12 by a 2. Okay, because 8 and 12 both go into 24. You could do 4 and 6. They actually both go into 24 as well, but we'd be multiplying different numbers there. All right, so I go ahead and distribute. I get 24x. I get plus 12y. And over here I get equal to negative 12. In the second one, I'm going to get minus 24x, which creates what we want right there. I get plus 12y actually for that one. And then 2 times that, I get a negative 24 right there. Now be careful, the x is eliminated, the y's do not. Even though they do match, they're both positive, so we're going to get 24y. The x's are eliminated, and I get equals negative 36. So I go to divide by 24, and I get a fraction. Not the end of the world, that certainly is okay. It actually works out to a negative 1.5 or negative 1.5, which isn't too bad, hopefully. So we go up here for our ordered pair. We got negative 1.5 right here, and we're going to plug this into whichever one we'd like. I'm going to go back to the first one, the 8x plus 4 times y equals negative 4. So I move in the y, the negative 1.5. I get 8x. Use your calculator for this. You can certainly use negative 1.5. When we multiply that, we're going to get minus 6. So actually it's not plus, it's going to be minus 6 is equal to a negative 4. I'm going to add the 6. I get 8x. Oops, I'm running out of space there. 8x is equal to 2. I divide by 8, and 2/8 will simplify into 1/4. So there you go. So go ahead and feel free to pause that if needed to fill everything out, and then 1/4 ends up being our x value. So there we go. We do get a couple fraction answers, but that is okay. Certainly not the end of the world. Hope everybody's doing well, and please reach out on Canvas if you have questions. Thank you.